So back with the second part of our solid waste management. We have looked at what is traditional solid waste management and what is integrated solid waste management. So let's just look at what is being done actually in the United States. So the left side compares what we should do, which is the ISWM, and reduce is the first option, followed by reuse, recycle, incineration, and bury. And on the right-hand side is what we are actually doing. So we find that it's an inverted scenario. The pyramid is completely inverted. We bury most of the solid waste. Some of them are recycled. Then we have incineration, and very little is reuse or reduce. So how to apply integrated solid waste management? First, we look at waste reduction measures. This is the first priority. It can be implemented at two levels, at the manufacturer's level and at the consumer's level. So the manufacturer, they can first of all redesign the products and packages to make less packaging. They can reduce losses and waste during manufacture. They can substitute toxic material with less toxic one. They can change the technology to make it more efficient, that is, produce less waste, and they can produce products with longer shelf life. As consumer, we can avoid wasting our products. We can also opt to buy selectively, that is, more products that are recyclable in nature, buy eco-labels, and use less toxic materials. We can do simple things such as using both sides of paper, buying in bulk, and also, in case there's a waste program in your community, please participate in those waste separation and recycling programs. Now, the second strategy in ISWM is recycling. It involves basically processing used materials into new reusable products. The first step is collecting those wastes that we produce. The second is converting the used materials to new products. And lastly, recycling can only be achieved if you actually use those recycled products. So there are three steps, and these are represented by three chasing arrows on your right-hand side. The green universal symbol is a Mobius loop. It shows the three steps in recycling. Now, recycling materials usually comprise of paper products, glass, aluminum, steel, and plastics. There are two types of recycling. The first one is called primary or closed-loop recycling. It is converting the product back into the same product, such as aluminum cans converted back into aluminum cans. And secondary recycling is where the materials recovered are converted into completely new products, such as used rubbers converted to rubberized road surfaces. Now, there are many advantages of recycling. The first being you reduce the consumption of new materials and minerals. Since you avoid the manufacturing process, you also reduce air and water pollution. There is less greenhouse emissions produced, and it reduces the amount of solid waste that will ultimately need to be disposed. There are some disadvantages to recycling. They can cost more in areas where burying spaces are readily available. They reduce profits for landfill and incinerator owners, and in some cases, the product produced, the recycled products, are of lesser quality than the original product, which makes it less easy for consumers to buy it. Now, the other step in ISWM is composting. This is actually just a form of recycling that is done in a natural way. So the proper definition is decomposting is the biological decomposition of organic substrates under controlled conditions to produce a final product that is stable, free of pathogens and plant seeds, and that can be beneficially applied to the soil. Compostable material are municipal solid waste, the organic fraction, anything that is from food and agricultural waste, wastewater sludges, yard waste, and sometimes special waste, including pesticides and residues. Composting can be done by individuals in their own backyard, or they can be done at large scale by municipalities using the windrow systems as shown in the picture. Now, benefits of compost. It directly applies the chemical cycling principle of sustainability. So all the nutrients in the organic matter are brought back into the soil and they are taken back by plants. It can effectively reduce all the organic fraction of waste. It is a valuable soil conditioner that improves the physical, chemical, and biological characteristics of soil. It does so by, for example, physical, it retains water content, so you have to irrigate less. Chemically, it adds more carbon and chemicals and nutrients back to the soil. And biologically, composting also adds worms and other microorganisms to the soil. So, of course, compost is most famous for reducing. If you use compost, you naturally reduce the dependence on chemical fertilizers. It reduces nutrients runoff by retaining those in the roots, and they reduce the amount of municipal solid waste that ultimately will need to be landfilled. Now, a very common option for solid waste management is incineration. It's also called the waste to energy. So incineration is the thermal conversion of waste materials into ash, gaseous products, and recoverable heat energy. There are basically three types of facilities, the most common one being mass burn facilities, where there is very little pre-sorting of the waste, everything is dumped and burned. There is a modular systems. These are small units that can adapt to demands. They are mostly used by clinics and hospitals. And lastly, there's refuse-derived fuel systems, where there is major pre-sorting that occurs and only the combustible part is sent for burning. This slide shows a cross-sectional view of what happens in a mass burn system. So as you can see, there's a blue truck there which collects the waste. All the waste are combined, there's no sorting. There's a crane system which picks the waste from the waste pit and feeds it to the furnace. As the waste burns, the hot air is sent to a boiler, and that boiler produces steam sent to a turbine and to a generator which can produce electricity. The spent air, that is the air after it has been sent for electricity production, it contains all the pollutants that results from incineration. And they're sent first to a cleaning process. They need to be cleaned before releasing the environment. This picture shows a wet scrubber. Basically, it can be water or another liquid water plus some scrubbing agent. It removes everything such as volatile organic compounds, acid gases, and ammonia are at this stage removed from the air. Now, the second step is precipitating all the solid part in the gas. It can be soot, it can be particulate matter, and you need an electrostatic precipitator that removes all this from the air. Once the air has been cleaned, it is released into the environment. If you can look at the bottom, there is a bottom ash, the dirty water, and the fly ash. These are all byproducts of incineration. The bottom ash is actually hazardous ash, and they all need to be pretreated before they are released back to the environment. Now, advantages of incineration. It is a very popular method of treating waste because the treatment is immediate. It takes seconds to destroy all the waste in the incineration. The waste reduction is dramatic. 80 to 95% of the volume is reduced. It is a very viable option where land spaces is limited. That is, there is no space for landfilling. And it also produces heat that can be used directly, or it can be used to produce electricity. Now, the disadvantages of incineration. They undermine reduce, reuse, and recycling efforts because you basically tell people you don't need to separate your waste, we can burn everything. It is a capital-intensive, high operating cost system, and most importantly, it produces a hazardous waste. and maybe you have heard of it, it is also highly polluting in terms of air pollution. The most feared are dioxin and furan pollutants, which are carcinogenic pollutants. Now usually the last option for waste, whatever cannot be reduced, recycled, or incinerated, are sent to landfills. This is disposal of waste in the soil surfaces. Historically, this has been the most common way of disposing of waste. You just put it in the soil, you just bury it, and you forget about it. There are few types of landfilling. The first common type in developing countries is the open dumps, as you can see the picture. These are very health hazard facilities. There's high risk of fire, high risk of environmental impacts. A second level where there is some kind of control are control dumps. So the waste can be covered, or some environmental controls happen at this level. And the last and the best one is a sanitary landfills. This is where you make sure you control most of the environmental impacts. This slide shows you a cross-sectional view of a sanitary landfill. The black part, the dark part, shows the waste in the landfill. So at the very bottom, you would see there is a double liner system, which consists of a compacted clay and perforated pipes running through sand layers, which are meant to collect all the leachate that are produced from the waste. Once collected, these leachate are sent to a pretreatment facilities. They are loaded with toxins and pollutants, and they cannot be released until they are properly pretreated by a wastewater pretreatment plant. Now, the waste is compacted on a daily basis. They're covered every day at the end of the day to prevent waste picking or vectors coming through the waste. And finally, after many, many years of operation, that can be around 30 years of operation, there's a final cover to close a landfill. Now, as you can see, there's pipes that run through the landfill. These are there to collect all the landfill gases that are produced during decomposition. Decomposition can be aerobic or mostly anaerobic in this case. Now, all the landfill gases are collected through those pipes, the vertical pipes, and they're cleaned and sent to a facility which burns the gas and produces electricity out of it. So at the final stage, the landfill, after it ends operation, there's a final cover on top of the waste. It prevents water and rain from coming to seep through the waste, and it can be rehabilitated in this picture. It's covered with green grass, and it can be used for other purposes. Now, note that this facility operates around 30 years, and for the next 30 years, it will keep on producing leachate and gas, and it has to be monitored over this period, even after the landfill has ceased operation. So this slide just summarizes what we've discussed. So advantages of landfill: these are low operating cost facilities. They handle large amounts of waste. The fill landfills can be used for other purposes, and they are very viable where land spaces are available. But these options are not really good for small islands where there's very limited landfill space. Disadvantages: this approach encourages production of waste. There's no significant amount of reduction or reuse. They produce noise, traffic, and dust. They releases lots of greenhouse gases, methane, unless they are collected, and they can eventually leak and contaminate groundwater. Now, we have seen that the best strategies for waste is to simply not produce the waste in the first place. Or if we cannot, we reduce and we reuse them, we recycle them. And if these cannot be implemented, they are incinerated, they are landfilled, and finally disposed of in the environment. Now, in the ideal situation, this concept of cradle-to-cradle design suggests that all products be made reusable and that all products can be discarded and are biodegradable. So this is proposed by McDonough. It's a cradle-to-cradle. We usually talk about cradle-to-grave, but in this one, all the waste, all the products used or at their lifetime recycled back, or they are made in biologically, so that they can be recycled again by nature, and they become part of the nature again. So it thinks of solid waste as potentially useful and economically valuable materials that can be converted back to nutrients and become again part of the ecosystem. Thank you for your attention.